Greetings. Welcome to my video response for Module 5, exercises 5 and 20. So let's look at number 5 here. 23 randomly selected athletes were chosen. It was found that the average was 17 hours for the workout per week with a population standard deviation of 2 hours. Assuming that the population is normally distributed, which is a fundamental assumption for everything we do in this chapter and everything else. They want us to construct a 90% confidence interval estimate of the average number of workout hours for all athletes. So obviously we can't go and interview every athlete on in the world or in US or wherever it is you're trying to investigate this at, and be able to come up with a certain value. Enough said about that. So we have to estimate it. So they want us to estimate the mean. So obviously they want us to figure out some kind of a interval estimate for the mean of a population. And I have it here on my Excel sheet, which I have calculated the numbers for you. But if I were to write it physically, 23 randomly selected, so n is 23 here. X bar, which is the sample mean, is 15. Population standard deviation, which is sigma, is 2. So sigma is given. So this is going to be a z situation. So to calculate the confidence limits, the lower and the upper, we're going to have to use the z formula or the z distribution to find the critical values, which is what they're called. And obviously the confidence level here is given to be 90%. We've been writing it as CL, but you could just use C for writing the confidence level, which is 90%. Now, if it's a z distribution, you all remember that the z alpha over 2 value, and that's just the notation again. The same thing as the z value, known as critical value here. For 90% is 1.645. So you've memorized this, but you could also achieve it by what you see here. You remember that what we do is we take the confidence level, we divide it by 2. So if I take 0.90, and I'm going to do it here in the middle, and divide it by 2, I get 0.45. And then if I add that to 0.5, I get 0.95, which is right there. And that's what I use to read the z-value. So basically my command will be the norm dot s dot inverse, and then you write the probability, which is 0.95. That's the half of the confidence level, divide by 0.5, so 0.95. And if you execute that, it will return that value for you. So let me just erase that, because you could just try it yourself, and you could also do it, and you could see it done here. Now, the formula is x bar minus z times sigma over square root of n, x bar plus z sigma over square root of n, where this is the margin of error. So basically, again, just to say it one more time, you notice that in order to estimate the actual mean of a population, you will use the sample mean that is possible to calculate, because you're only based on 23 people, so it's not an impossible thing to do. And then you calculate the error involved in the computation, and then it basically be x bar minus the error will bound the mean, and x bar plus the error. So you basically, it's like an estimation, like an estimate, like a plus minus. So you're estimating the average with the sample average plus or minus some value. Now, once you've done that, oops, I erased too much. Once you've done that, then you just plug in the values you have in a spreadsheet. So I'll plug it in 15 minus, I'll play along, 1.645. Use 3 decimal places for the z value there, and sigma is 2. My sample size is 23, and the other side will be the same thing with a plus in between, because it's plus the error, and here's the error, sorry, 1.645 times 2 divided by square root of 23. Now the computations of this are done on using technology on calculators or spreadsheets, but since calculators are yesterday's news, we're going to use spreadsheets to calculate it, and I've calculated it for you. I'm not going to do computations here. These are the answers. So my final answer, if I write it in red, let me just erase all this stuff except the formulas. Okay, so if I want to just write the answer, it will be, and let's say I use one decimal place, it will be 14.3 mu, and it will be 15.7. And that will be my response to that question. So I am 90% certain or confident that the actual mean number of workout hours for all athletes is somewhere between 14.3 to 15.7 hours. So that was number 5. For number 20, here we're asking us to do a 95% confidence interval estimate of the standard deviation of the number of pages in the calculus textbook. Now, if they're asking me to construct the confidence interval for the standard deviation, then I'm going to be using the standard deviation confidence interval formula. And this you do not need to memorize. You have the formulas given to you on a formula sheet. So, and that's right, this is the left-hand side, or lower confidence limit, upper confidence limit, and yes, I know you've noticed that. It says right side, but it's on the left side. That's how it works, and that's the formula. You want the left side to be smaller, so obviously you have to divide by the larger number. So therefore, the larger value goes on the left. And remember, if you're drawing the chi-square distribution, and that's your chi-square axis, and that's your probability axis, and that's 0. Now, if you're doing a chi-square distribution, guys, as you recall, chi-square left is the value there, and chi-square right is the value here. And chi-square left is always smaller. So since the left-hand side has to be smaller, you divide by the larger value. And since the right-hand side has to be larger, you divide by the smaller value, so that's why the reverse of the actual notation, so don't be confused, that's not a typo. Now, so what do we need for the formula to plug in? We need n minus 1. Here it says a sample size of 6. My sample size, I've typed it here, that's 6, so 6 minus 1 is 5. My S is given to be, my standard deviation is 17. So my S is 17, which means my S squared is just 17 squared. And I need to find my chi-square right value and chi-square left value. Now, we've seen the commands for these, but we'll do it again here. Now, in order to find, and of course I've calculated it for you here, and I've actually shown you how you're going to go about doing it. Now, what's my confidence level? My confidence level here is 95%, so C is 95%. Instead of CL, you could just write C. That denotes the confidence level. Now, what probability do we use for the chi-square calculation? And you always start with chi-square right. And if you recall, what we need to do is we need to calculate 1 minus the confidence level, which is 1 minus 0.95, which is 0.05. And then we need to take that and divide it by 2. So 0.05 divided by 2, that gives me 0.025, and that's what gets typed in the chi-square formula. Okay, so and I want to show you this, continue showing you this on a spreadsheet, because that's the best way to see it. So let me switch my view back to a spreadsheet. There's my spreadsheet, and here you notice chi-square, and if I double click on it, so I'm typing the chi-square dot inverse dot right tail, chi-square dot inverse dot right tail of B5, or B5 is 0.025. So you could have just written 0.025 with n minus 1, which is 6 minus 1, which is 5 degrees of freedom. Oops, it didn't like it, so it just wants 0.5. Okay, I forgot to delete the B5. There you go. Now we'll do it. So anyways, so either you type B5 or you type the actual literal value, which is 0.025 in this case, you get the same answer. And for the chi-square left, you see, you just do chi-square dot inverse, so you just don't type the RT, which is the right, and that by default gives you the left. And that's what you use in the formula. So if I show you the formula, you see you have square root of 5 times S squared, B2 squared, divided by Since it's the left-hand side, you divide by the larger value, which is chi-square right, which is in B6. And there's that. So let me so I just wanted to show you that. Let me go back to my notability lecture, and let's just continue writing that for you. So you've seen the commands for chi-square left, chi-square right. So this will be 12.83250,199. Of course, you have to worry about typing all this, because if you're answering this computationally on a test or an exercise, you'll just be calculating these values on a spreadsheet like I have here, and you'll just be clicking on it and you capture the whole thing. So you don't have to worry about how many decimal places to carry. And this one will be 0.831211613. And that will be the chi-square left value. So now if I substitute, let me delete this. Now if I substitute all of this in the formula, I have, and I'm only going to do it for one side, actually I can do it for both sides, n minus 1, n is 6, so n minus 1 is 5, times s squared, which is 17 squared, divide by chi-square right, which is 12.832 . And then on the other side, you have again n minus 1, which is 5 times s squared. That part's the same. And then you divide by chi-square left, which is 0.8312. And then the final answer will be 10.6 if I'm looking for one decimal place in the final answer, and 41.7. So that will be my final answer. Oops, what happened? There you go. So that's my final answer. Thank you.